V44 begins on slide 83 and covers the concept constant of proportionality. Please make a note in large letters the two following important equations. The first one is y equals kx, and the second one is k equals y over x. Now, if you remember from yesterday's lesson, y equals kx is one of the equations that's used to show direct relationships. Well, k stands for the unit rate. In the second equation, k, or the unit rate, equals y over x. And as we did in class, y divided by x will give you the unit rate. So k is another way to write the unit rate. Slide 84 shows you the constant of proportionality as its definition. So the constant of proportionality is a constant ratio or unit rate in any proportional or direct relationship. And K is used to represent the constant of proportionality. The equations, again, are y equals kx, or k, the unit rate, is y divided by x. So just to make this clear, unit rate, k, and constant of proportionality are all the same concept. I can say the unit rate, substitute it with k, or say the constant of proportionality. The three terms mean the same thing. So in order to find the constant of proportionality, or k, or the unit rate, we first have to determine what x and y are. So we have students and chaperone. Well, we typically say students per chaperone. So chaperone is going to be my x, and students are going to be the y. So in order to find the unit rate, it's going to be y divided by x. So y is 12, x is 1, 12 divided by 1 is 12, 24 divided by 2 is 12, 36 divided by 3 is 12, 48 divided by 4 is 12, 60 divided by 5 is 12. So we say that k, or the unit rate, or the constant of proportionality, is 12 students per chaperone. Slide 86 is giving us apples and cost. Well, first I want to determine what's x and what's y. So I would say cost per apple. And since the cost comes first, cost represents y and apples represents x. So now I have to find the unit rate of each ratio and see what I get. So if k equals y divided by x, I have 3.96, which is y, divided by 2, and I get 1.98. Please pause the video and use your calculator to find out if 1.98 is the constant for the remaining 4 ratios. Slide 87 is another example, except the table is vertical, not horizontal. So the constant of proportionality, k, equals y over x. So k equals y divided by x, and I have to test every single one. So this example begins with the whole number 12 and 8. 12 divided by 8 is 1.5. And I did the work for you. I tested the remaining ratios. 4.5 divided by 3 is 1.5. 6 divided by 4 is 1.5. 7.5 divided by 5, and so on. Since they all equal 1.5, I can say that k equals 1.5. And that is my unit rate. Please pause and complete slides 88 through 90. Remember, when you're finding the unit rate, you have to test every single ratio to ensure that it's a direct relationship. Slide 91 is now working on the second equation that we began with, y equals kx. So remember, a unit rate equals y over x, and we say y per x as our label. Y comes first, x comes second. These problems should be pretty simple. If y equals kx, and we have to find out what k equals, well, here y equals 5x. So I don't know y, I don't know x, but the only number that's plugged in is k, so therefore k must equal 5. The second one, y is unknown, x is unknown, but the only number substituted in is k, so k equals 1/4. And finally, y is unknown, x is unknown, the only substitute is 3.5, so k equals 3.5. So the unit rate is 5 in the first one, the unit rate is 1/4 in the second, and the unit rate is 3/5 in the third. Please pause slide 92 and figure out what the unit rate is for each of the 6 problems. The first one is going to be 3.6. Go ahead and finish the remaining problems. Once you have finished with slide 92, please pause and complete responder questions 93 through 95. You're writing what the constant of proportionality is, or k, or the unit rate. They are all the same concept. So remember, in class we talked about a table, an equation, and a graph all being able to show direct relationships. We're on the third topic, a graph. So you can find out what the unit rate is in a direct relationship by looking at a graph. Well, slide 96 shows an example. You have to pick any point on the straight line, and you have to ensure that it goes through the origin and is a straight line to even have a constant of proportionality, or k. Otherwise, if it didn't go through the origin or if it wasn't a straight line, it would be indirect and it wouldn't have the same constant. So this does meet 0, 0, and it is a straight line. So let's look at point 224. So ordered pairs work with x first, so you move over x and then you go up y. So I move over 2 and I go up 24, and here's my point. Well, k isn't x divided by y, it's y divided by x. So when you have your ordered pair, it's really important that you remember to flip the numbers. I'm not doing 2 divided by 24, I'm doing 24 divided by 2. So k equals y over x, which is 24 divided by 2, which is 12. So therefore, the unit rate is going to be 12 students per chaperone. How did I know that students came first? Because students is on the y-axis and chaperones is represented on the x-axis. And remember, it's y first, x second. So 12 students per chaperone. Slide 97 is another example. So we have to pick an ordered pair, and I'm going to pick 9, 15. So on the x-axis, I go over 9, and I go up 15. So here I am. Remember, I have to flip the numbers in order to find the unit rate. So it's not x divided by y, it's y divided by, sorry about that, y divided by x. So k equals y divided by x, and y is 15, x is 9, so 15 divided by 9 is 5 over 3. In this case, the y-axis doesn't have a label, and the x-axis doesn't have a label, so I'm simply going to say that my unit rate, or k, or constant of proportionality, is 5 over 3. Please pause and complete number 98 on your own. Once you are finished with 98 only, you are done. Please write done in nice big letters at the bottom of slide 98.